Looking out my own window to the universe at these superclusters, just billions and billions of stars. Hey, everybody, how are you? I'm Marquette here to bring you some backyard astronomy on Stay Star Curious Monday here today at the American Space Museum. Glad that you could join us today. I got my binoculars out because this week is a great week to look out at millions of galaxies from your own backyard. Now, you're not going to see any of these galaxies with your naked eye, but you'll see a few of them with some binoculars, and you'll see a few hundred more with a good telescope, but you're going to have the Hubble telescope or the Webb telescope to see the millions and millions of galaxies that exist out your own backyard window, okay? And so I'm going to make you feel a little bit insignificant today, but that's all right because we're humans. We got a big ego. We know that all we're concerned about is about what's in front of us. But I think you're going to be amazed at really how big this thing called the universe is and what we really don't know about it. And we're going to come up with a new saying here at the American Space Museum, thanks to my executive director, Karan Conklin. We're going to start saying, know where you've been to know where you're going. And there's nothing new except every day there's something new. When the Webb telescope, Hubble telescope, all these great instruments on Earth that are trying to figure out the universe, every day is a discovery day, and we're going to show you some discoveries there. To know where we've been, we need to know this universe, 15 billion years old. We need to know how it started, how it's put together, and then we'll know how long we're going to be around. So, well, with that, we're going to just kick off a little bit of Star Curious here with letting you know that you get your binoculars, you get a red flashlight. The red flashlight is so that you can read your star chart under the dark night, because red light does not let your pupils contract after they've dilated out. And we talked about that before. Let your eyes adjust to the night sky. This is a great time of year to be going out into the night sky because it's summertime and you're out of school if you're a kid, or you may be a little lazy at work and you can sleep in a few days. But I wanted to show you in our window of the universe here, our star chart, that you can download some sky star charts here. This one is from Sky Maps. We're going to talk a little bit about these. This is Sky Map for June. Summer is stargazing time. I remember as a kid that I loved it because I could stay up all night. My buddy Hal and my other buddy Greg, that are still stargazing buddies, we would stay up all night watching the wheel of stars move overhead, because as the Earth turns to the east, everything appears like it's going to the west. And literally, as you're out for hours under the sky, you notice how things have changed and the sky's changed on there. So Marty, my co-producer, just made my star chart there a little smaller. Thank you, sir. Wanted to give a shout out to him as we start another week of Stay Curious, actually episode 836 in our fourth year here of sharing space history, and it's evolved into sharing some stargazing with you, at least tried to once a week, but at least a couple times a month. So star wheels are really cool. They've been around for a long time. The planisphere is the correct term. Planisphere. There's a big version and a small version. Around the edge is the date of the month, and you just simply line up the time that you're observing. So let's say we're out at 10 o'clock at night, and I set up the 10 on the wheel. Here is a 10 with the appropriate month as I go around to June, and put 10th there about the middle of June, and then you see what's here. And you hold it over your head north, looking north, and hold it over your head south, looking south. And just laying on a lawn chair, studying these planispheres, which I have one here that is over 100 years old. That's from 1906, this Starfinder, all right? Just to give you an idea how elaborate. They were kind of like a kaleidoscope that people enjoyed making them different ways to put different things on them. But the stars are always the same. They have not changed their positions in hundreds of thousands of years to human eyes. And so that is the roadmap that we use to look up at the sky. But now when we're looking at every star in our night sky, it belongs in our Milky Way galaxy, all right? There's only one little faint patch of the sky that we see that's not part of the Milky Way, and that is the Andromeda galaxy. And that's in the fall, and it's 2.5 million light years away, yet you can see that with your naked eye. But they thought it was a nebula until photography proved that light was individual stars. So as we're looking at the night sky and the individual stars out there in the sky, you got to remember they're all part of our Milky Way galaxy. And Marty, would you believe it that just in 1900, 120 years ago, everybody believed that the Milky Way galaxy was the entire universe. That's what the universe was thought to be, the Milky Way galaxy. All right? And it took a man named Edwin Hubble to discover that with photography, that there were these patches of light weren't cosmic clouds creating stars. They were galaxies beyond the Milky Way. And using scientific things like parallax and spectroscopy, he discovered that, this is Edwin Hubble, discovered that the galaxies were moving away from each other in opposite directions. And that is the big red shift theory, where everything in their spectrum shifted to the red end or the far away. So a tremendous discovery just 120 some years ago, where we realized our Milky Way galaxy wasn't everything. That the Milky Way galaxy of just 200 billion stars was one conglomerate of stars in hundreds of trillions of galaxies. Galaxies we're talking about, each with hundreds and billions of stars. There are now trillions and trillions of galaxies spread out across the universe. Now, this is what the Hubble's trying to figure out, is how big is the universe? Does it have a finite edges? All right, for example, what holds the universe in place, so to speak? This is a whole cosmological question that, quite frankly, I don't think human beings on Earth have the brains to figure it out yet. You got to know where you've been before you know where you're going, and we don't understand exactly where we're at. Truly, when we thought 100 years ago that where we were at was the entire universe, oh no, we're just a little speck in this universe, and our speck is not Earth. It is the Milky Way galaxy. It's just an average Joe Schmo thing out there in the galaxy, in our whole Milky Way scene. So, to set the stage a little bit about some of the distances I'm going to talk about, let's talk about a light year. Okay, you all know that a light year is a rule, kind of a yardstick for distances, but it deals with time. If light goes 186,000 miles a second, that is 6 trillion miles in an hour, all right, is its speed. It goes 6 trillion miles in a year, I mean, the speed of light. But you can't comprehend that, but you can comprehend this. If I took a little photon of light, put it on a railroad track going around the equator, our equator is 26,000 miles around. The Earth is 26,000 miles around. So in 1 second, that ray of light would go around the Earth how many times? 7 times. It would go 7 times. You'd never be able to cross that track if a photon of light was on a railroad track going around the equator. It'd go around 7 times in 1 second. That's 25,000 miles around. The sun at 93 million miles away, which that doesn't sound too far, Mark. 93 million, you know. Well, it takes light going to 186,000 miles a second. It takes it 8 minutes to go from the surface of the sun to our eyeball on Earth. Think about that while I sip a cup of coffee. 8 seconds, we're looking at the sun, time delayed. So when we start talking light years, the closest stars to Earth are 4 light years away. That is the Alpha Centauri system, and it's in the southern hemisphere, just below the horizon to all of us here in North America. So 4 light years is the closest, and the brightest stars, like Sirius is the brightest star in our sky, that's about 8 light years away. So it makes sense that most of the bright stars are close, though there's a few exceptions. They're just big powerhouses. So as we start looking further and further, it's interesting to know that when we're orbiting, the Earth is orbiting the sun once a year. So as we look out into the night sky, it's sort of like looking up into the grandstands at an oval racetrack, whether it be race cars or horses. And you're looking up in the grandstands, and that's night, but looking in the opposite direction, that's day. All right, so you're not going to see the people in the grandstands opposite what you're looking at. That's where the sun is, in the middle of the track. So as we are orbiting around the sun, we are in a period of time in the springtime when we're looking out into the sky, and we're looking out away from our galaxy. All right. Most of the time we're looking sort of into our galaxy. In a few months, the Milky Way will be in our night sky. You can see it at about 3 in the morning, but that's when you're looking towards our galaxy. You're looking towards one of the gigantic arms of our galaxy. So as I put up this illustration, is to show you that the stars, as you look south, are void of a lot of bright stars. Okay, we have Venus and Mars are together in the western sky after sunset. This is about 9 o'clock. But you've got the you got the constellations Virgo, Leo the lion, Hydra the snake, Crater, Corvus the crow we talked about. Not many really bright stars. Spica is a bright star, and Regulus is a bright star in Leo. Other than that, there's just a handful. So these constellations are hard to figure out and look at because the stars are so faint. Why aren't there many bright stars? Because we're looking away from our galaxy. We're looking out into the rest of the universe, all right? If we're driving our car in the solar system and the driver's headed towards our Milky Way galaxy, we're looking out the rear view mirror, all right? And we're seeing what we thought was a void of space where not much is in it. But what we did discover is galaxies. And there's a Virgo cluster in Virgo, the chain maiden, the maiden there. And also some significant galaxy clusters in Leo the lion that we're going to look at from a backyard photographer in Florida here, a good friend of mine. You're going to see some of Mark Poole's pictures of these galaxies in Leo here in a minute. Typical of galaxy time. So that's what we call spring, is galaxy time to amateur astronomers. And what we're going to do is go from the Earth to our solar system there at the top, then our solar interstellar neighborhood of close stars, and then we go out to our galaxy. And I'm going across the panels at the top there. And our galaxy looks a little bit like that. I'm going to show you a better picture of it. And where the red is, that's where our sun is. All right. But our sun is just in a group of galaxies. It's called the local galactic group of about 30 galaxies. Some are smaller, some are larger than ours. And this local galactic group is part of a Virgo supercluster of galaxies that number a couple hundred galaxies. All right. And then the Virgo supercluster is in a group of local superclusters. So what we have found with the Hubble telescope, ground observations on Earth, and we're going to solidify with the Webb telescope, is that galaxies clump together because of gravity. Just like planets clump together around a star in orbit, stars clump together in galaxies, galaxies clump together in clusters of galaxies, super clusters of galaxies become super clusters of galaxies, and it is truly mind-boggling. Well, if we could look down on our Milky Way galaxy, we're pretty sure that it looks like this, because we would have to send a space probe for a journey of about 26,000 light years to see this. Our galaxy is about 100 light years from end to end. So it takes 100 million years, 100 million years to go from one edge of the galaxy to the other. All right. And we have we're called a barred spiral, Marty. Notice that the center is not a concentric circle. It is almost like a little bar. And we know this observation from observing other galaxies nearby, that this is a pattern that galaxies take. Galaxies, we take a life cycle. It looks like a tuning fork. All right. And the tuning fork comes down and centers into the fork part is where galaxies coalesce to more like just elliptical galaxies with no arms. Why we have arms, we don't know. What's being created in the arms, all that red that you see in this are stars being formed. And this is a galaxy that looks very similar to the Earth. Well, as we go here, there we go, let me go there. So there is our sun. This is like stripping away a lot of all the stars and just showing you the main arms of our galaxy. We thought we had 4 or 5 spiral arms. Now we realize that we just have these couple spiral arms that are wrapping around each other. And there again, I center the sun is at the lower bottom there. All right, so we're kind of on the outside edge, a good place to look out. As you can see, looking down at the bottom towards the Perseus arm, that is looking out into our universe. Looking to the scutum cloud, we're looking into the center of our galaxy. All we see are stars and artifacts, nebula, and other things that are in our own galaxy. Here's another another artist rendering to show you our solar system. You see it marked there, center down at the bottom. They chop it up in quadrants so they can talk about the distances involved. Okay, 200,000 light years, 300,000 light years, 400,000 light years. We're about 500,000 light years, or 50,000 light years, I mean, in diameter, 100,000 light years across there. Not million of light years, there's just 100 there. It's easy to lop that in. And what we see are some incredible views. The stars with the hashes, with the hacksaw points on them, those are stars that are in our own galaxy. And those cross points are caused by the physical artifacts of the Hubble telescope. All right. But you're seeing some, maybe over 1,000 galaxies. All the other points here are galaxies in some form of evolution. Now, what the Webb telescope has discovered is exemplified by this, a little astrophysics here. On the left side, stars were formed and galaxies were assembled hundreds of millions of years after the Big Bang. The Big Bang is what we call the beginning of the universe. We think it happened about 15 billion years ago when from some singularity point, everything we see was created. Now, I know that sounds pretty exceptional to say that, but we're going to learn more about this thanks to the Webb. The Webb telescope has already made this amazing discovery. In the early universe, the gas between the stars and galaxies was opaque. It was thick. You couldn't see through it. That's what opaque means. Energetic starlight could not penetrate it. Therefore, galaxies next to each other couldn't see each other, or neither could, because the starlight was not penetrated by the dense cloud of the Big Bang. But about 1 billion years after the Big Bang, gas had become completely transparent from the left panel to the far right panel. Clear universe, an opaque universe. Why did this happen? Well, new data from NASA's Webb Space Telescope have pinpointed the reason. Galaxies, stars emitted enough light to heat and ionize the gas around them, clearing our collective view over hundreds of millions of years. In other words, the fog lifted. Our universe began in a fog of stars, and the galaxies, the stars coalesced into galaxies. So this fog began to change. Gas around them began to create bubbles is what the physicists are calling it. And areas of these big bubbles of gas transformed, expanded, and so to speak, the fog lifted, and now we have a transparent, clear universe. So, but you didn't know that the universe started in a fog and you needed light to see your way around back in the day, 15 billion years ago. So we don't know why that happened. This is part of the scientific process, but it is a great new discovery by the Webb telescope that is just a year. It was launched a year ago on Christmas Day. So think about that. Now, as we look at these gigantic images here, look at this image of more galaxies, different shapes, sizes. The colors give us an idea of whether they're receding from us or coming towards us. Thousands and thousands of galaxies in here. And as I go the wrong way, Peach Fuzz, let's look more at your window of the universe here as we take you to your own backyard to look out this window of the universe. Let us first look at the constellation again of Leo the Lion. Leo's where the sun was if you're born in July. All right, the sun is getting into Leo here in just a few months. All right, so Leo's high in the western sky at sunset. And the main of it is the backward question mark on the right. On the left is a triangle with the bright star Dead Nebula, which means tail of the lion. Regulus means a king star. And underneath his belly are two groups of galaxy clusters. And they have the designation M for the Charles Messier astronomer. Charles Messier was an astronomer in the 1700s that charted over 150 objects that looked like comets because they were faint fuzzy, but they didn't move. So he wanted to leave a catalog so other people wouldn't waste their time looking at them. And they just looked like little dust balls under your bed, little in a telescope. I've seen all of them. They're little faint fuzzies, we call them. But under photography, they become more than faint fuzzies. Even some you can see individual stars. They're so close to us. But they are more defined, as we're going to see here with this photograph from my friend Mark Poole. This is not Mark Poole's photography. This is another gentleman named Schmidt. This is M65, M66 that I showed you. Our M65, M66 under the loin of the lion, if you will. And this is how they look in a modest photography. All right, a bright center, whirling edges. And you see the NGC, which stand up the galaxy up the top right. New General Catalog, that's what that means. And it has a catalog number, 3628. And Marty, that looks like a sandwich with the dark lane there. And astronomers call that the Hamburger Galaxy. And they've named a lot of these. There's the Tadpole Galaxy. There's the Mice Galaxy and stuff because the way they look bring on some characteristics, and so they tag them with a name on there. So this is this is my friend Mark Poole's photography of M95 and a couple other galaxies that are in Leo there. These are and their distance there is this is the Virgo cluster. That's where I wanted to get. Okay, this picture of this area is a Virgo cluster that contains 1,000 galaxies. Everything you see in this picture here in a minute will be not everything in this picture, but there's maybe 20 galaxies in this there. Let me get my line of sight there. Yeah, that's where I'm at with the M95 and M96. I'm ahead of myself with the Virgo cluster, all right? This is M95 and M96. These are two clusters that are not galaxy that are in Leo there at the bottom. So 66, 65, 96, and 95 in a companion galaxy through an amateur astronomer's telescope there. And you can see these like faint fuzzies with binoculars, all right? Held very steady with a binocular mount which are easy things and cheap, affordable to buy. Now we get to, this is another cluster that's up in your backyard, okay? This is going on. This is called Stephan's Quintet. It's actually 3 galaxies that are interacting with each other, while 2 galaxies, one's in front of and one's millions of light years behind it on this. And this is a low power, maybe 100 power exposure with a pretty high-end photographic gear, of course digital. And how amateur astronomers do this is take a series of 2-minute exposures and stack them on top of each other. I'll explain that here in a minute. Stephan's Quintet. Now, my buddy Mark Poole, we have all these stars and galaxies. Stars go through life cycles like human beings. They are born and they die. And occasionally we see in distant galaxies stars die. And this happened just last month. Here, my friend Mark Poole in India Atlantic, just about 40 miles south of us here, on May 9th, 2021, photographed the Whirlpool Galaxy, M101, which is a very popular, easy-to-find galaxy. This M101 in Ursa Major, the Big Bear, which has, again, when you're looking at the Big Dipper, you're looking away from our galaxy into the universe. So it was reported that a star appeared where there wasn't one in that long arm that you can see there. So May 27th, Mark took this picture. The distance is 21 million light years. So 21 million years ago, this star blew up, and we're seeing it 21 million years as the light traveled that far to reach our retinas. And it's just so spectacular to see with your own eye. You can see that the star is there, all right, with your naked eye in a telescope. What does he say about that? So that is fabulous in itself. Now this is the neighborhood of M100, okay, in the Virgo cluster, all right. This picture is just one small section of the Virgo cluster. It contains over 1,000 galaxies. Everything you see in the picture in this is a well-defined circle, is a star in our own galaxy, and anything else is a extremely massive galaxy that is millions of light years away. So you can see in here, Mark said he counted 21 fuzzies. Their distances ranging from 50 million to over 100 million light years. So you see a little cigar-shaped thing down at the bottom. These are stars, the round points, but the one way up above me that's oblong shaped, that's a galaxy. You see the Whirlpool Galaxy up there. You see other galaxies in there. Over 21 galaxies, each containing hundreds and billions of stars, all right? And this is an area of the sky that is probably about 5 degrees, which is take 3 fingers and hold them out at arm's length, and that's the area of the sky that this would cover up. So pretty big area in there. Mark took this picture by stacking 133 photographs, each 2 minutes long. That's how they do this. And computers stack it, and it's all pretty computerized and scientific. Of course, in the world we live in, astronomy is one of the bigger booms of how to see things in there. So pretty incredible that from your own backyard you can look up, and this is in Virgo, and like I said, Virgo's right there to the south at 9 o'clock at night, and you can imagine, though you can't see them, thousands and thousands of galaxies looking back at you. You go ahead and wave. I know you want to. Somebody could be waving back. Without a doubt, somebody's waving back if they're up looking out like you are at the stars from their perspective galaxy. And why do I say that? Because, Marty, we now know that the closest stars to Earth all have planets going around them. So if most stars have planets, then you just roll the numbers. My gosh, it's just unfathomable. I think the universe is teeming with types of life. Well, as I said, to boggle your mind, we are part of our Milky Way galaxy, is part of a local group of galaxies, okay? And here is what's called our local group of galaxies, is in the center. And then off to the right is where you have the Virgo cluster with all those hundreds of thousands. That big splotchiness in the right. This is sort of a 3D impression to kind of give you an idea with the lines and stuff, give you a 3D feel that you're sort of in a fish tank. Because all these things go in different directions, Marty. Some are behind us, some are in front of us, some are above us, some are below us. You can't really get that perspective when you're standing outside on top of the Earth. But then I go out further, and now we got a whole bunch of local superclusters watching us there, okay? And so that's makes it even more interesting out there. And Marty just handed me some names here of people watching us here. Let me see there. Well, I see you there, Dave Stangy. He's got shorts on, Marty. Boy, he's glad he gets short weather in Michigan up there. And I just talked to Kenny Gordon today. Kenny, great, nice to make your acquaintance. He's staying star curious with us today, and mind boggled, of course. Doug Forrest, let me see what Doug's up to, Marty. If I look over, oh yeah, Doug's in California. He's got a number 4B pencil in his hand. He's really drawing that black in today on his artwork today, I can see, Marty. And Tom UCX watching there. I thought about you, Tom. Marty, did you see in Pennsylvania the overpass that fell down? And, yeah. Oh my gosh, I bet the UCX have been over that a bunch. Robert Law, let's see what kind of cocktail you're drinking. Beefeaters again, He's up there in Dundee, Scotland. Robert Law is. Hazel Banks, hello Hazel. Litza Delaporta's watching. Lynn McDaniel's watching. Thank you, Lynn. She's over in Tampa. I'll bet Connie McDaniel's watching, too. She's over here on the Space Coast. James Sigler's watching. Joel Jacobs. Space Monkey. Where is that Space Monkey, Marty? I don't see it up there in the skies, but Space Monkey's watching, as is Will Tigers today. So thank you all for staying curious today and letting me blow your minds a little bit, because the clusters are super clusters and clusters of clusters. It's amazing. And right here is 1,000 galaxies in here. Every one of these images is a galaxy, folks. Some of them could be 10 times bigger than our Milky Way galaxy, and which we know is pretty much just an average size galaxy with 200 billion stars in it. So, no big deal. But as I make you feel insignificant as we go to the observable universe above me here, all the way from the local supergroup to the Virgo supercluster to the local group to our Milky Way in the local group to our place in our stellar neighborhood, to our solar system and the beautiful blue Earth. I'm telling you, you got to get outside and soak up a little bit of this cosmic energy, folks, because it's out there. I've been doing it for years. Some people say that's why I'm the way I am, but I seriously do go a little crazy without starlight. And so go out there and grab you some starlight out there. Get you some starshine. The moon's out of the way this week. It's in the after midnight scene out there. So the faint fuzzies I've been talking about are beautiful to see. I encourage you to go out, get you a star chart, okay? There's my 100-year-old one there, the planisphere, and here's the 21st century version, the 20th century and 21st century. Spend a little time out there. Stargazing is not something you just go out and think you're going to do it for 10 or 15 minutes. You really want to devote an hour to it. And I guarantee you that the sights and sounds of the night will intrigue you just as much as the stars overhead, okay? Find you a good place in your backyard, block that street lamp a little bit, getting underneath the shade of that tree in the night. Let your eyes dark adapt. Get you a nice beverage to drink. Maybe have the ear pods in, listening to some Holtz's Planets or something like that. And start out with simple binoculars and just look around. I guarantee you, before you go in, after an hour of viewing, you're going to see some things that are going to go like, I think that was a satellite, and or what was it? And like I said, it's just a good way to connect and in my case, it's my spiritual place that I find is my happy place. So, folks, thank you very much for enjoying a Star Curious on Stay Curious. We will have some shuttles of the month of June coming up this week, and maybe a guest or two. So I just want to thank everyone for taking your time to watch today's episode, and we hope that you tell your friends about our special guests and programs that we offer on our program through the American Space Museum. Stay Curious will constantly strive to offer space history and give you astronomy like no one else. So until tomorrow, I'm Marquette saying I can't wait to see you again to bridge the space between us. And there's Mark Usiak. He's eating a Milky Way.